In the vast and restless silence of our solar neighborhood, something unusual is unfolding. A visitor, immense and enigmatic, is moving toward our sun. It is not a comet that we know, nor an asteroid that fits our catalogs. It is an object unlike any we have ever seen, a wandering mass roughly the size of Manhattan, known to astronomers as 3I Atlas. For months, telescopes around the world have been tracking its every motion, noting its changes, its flickering colors, and the sudden emergence of what appeared to be a cometary tail. Yet with every new observation, the mystery only deepens. At first, it seemed simple, a celestial body on a parabolic path, perhaps flung from the cold reaches of the Oort cloud, drawn now into the gravity well of our sun. But as the days passed, something felt off. The object's reflectivity shifted in unexpected patterns. Its trajectory curved in subtle ways that gravity alone could not explain. And then, without warning, it seemed to lose a fraction of its mass, as if something within it had come alive. Scientists are cautious by nature, but caution cannot conceal the thrill that courses through the research community tonight. What is this thing? Why does it behave as if under control? 3I Atlas is no mere rock. It is a statement from the cosmos itself, a question written in light. It is being studied not by one observatory, but by hundreds, by the twin sentinels of the Hubble and the James Webb space telescopes, by radio arrays stretching across continents, by amateur astronomers who stay up through the thin hours of the morning, recording its faint shimmer as it edges closer to the inner solar system. The collective gaze of humanity has turned toward this single, uninvited traveler. What has drawn so much attention is not only its size, nor its path, but its behavior. As it swept through the plane of the planets, a chance alignment so improbable that one astrophysicist calculated it at 1 in 500, the object began to alter its course. Some said it was merely outgassing, the familiar shedding of volatile ice as sunlight warms a comet's surface. But others noted a precision to its movement that seemed to defy randomness. Could it be natural, or could it perhaps be something else? Among those leading the discussion is Harvard astrophysicist Avi Loeb, known for his bold but rigorous inquiries into interstellar anomalies. To him, dismissing such an event without deep investigation would be reckless. He speaks not of certainty, but of curiosity, of science as a practice of humility before the unknown. If you found something in your backyard that doesn't look like any rock you've ever seen, he once said, you don't just walk away. In the coming weeks, 3I Atlas will reveal more of itself. As it approaches the sun, it will pass through zones of intense radiation, perhaps shedding material, perhaps illuminating its composition, or perhaps doing something altogether unforeseen. When it emerges again, turning back toward the darkness beyond Earth's orbit, our instruments will be ready, waiting to capture every reflection, every faint signal, every trace of what it leaves behind. The scientific world holds its breath, not because this is the first time we have watched a comet, but because never before has one behaved quite like this. It carries the quiet possibility of a revelation so profound it could shift our understanding of what lies beyond. Whether it is a relic of cosmic birth or a messenger of something far more deliberate remains to be seen. But for now, we watch and we wonder, because somewhere in the depths of space a Manhattan-sized object has turned its gaze toward our star, and perhaps toward us. In early October, telescopes across both hemispheres began registering a faint, slow-moving glimmer near the plane of the planets. At first, astronomers thought it was a minor comet, perhaps one of the countless fragments of frozen debris that wander the solar system. But within days, the data suggested something different. Its albedo, the measure of how much light it reflected, began to shift rapidly. The object, soon to be designated 3 Atlas, showed a shimmering quality inconsistent with dusty ice or carbon-rich rock. Instead, its spectral signature hinted at a surface composed of complex layered materials, possibly metallic, perhaps even manufactured. The discovery was first catalogued by the Atlas Survey in Hawaii, the same system that monitors the night sky for near-Earth asteroids. From that moment, observatories from Chile to Spain began tracking it, each refining the calculations of its orbit. The result startled everyone. 3I Atlas was coming directly toward the inner solar system, its trajectory aligned almost perfectly with the ecliptic plane, the flat disk in which all the major planets revolve. The odds of such an alignment occurring naturally were, according to Harvard astrophysicist Avi Loeb, roughly 1 in 500. It was a coincidence so rare that it immediately drew global attention. Over the following weeks, astronomers documented an even stranger evolution. As sunlight began to strike its surface more intensely, the object's color changed from a pale bluish hue to a warm reddish glow. A thin shimmering trail formed behind it, a faint cometary tail. That would not have been unusual for a normal comet. Volatile compounds often sublimate and release gas as heat increases. But then came the moment that shifted the conversation entirely. The tail vanished. Images taken just days later by the European Southern Observatory revealed an object that was completely clean, without the diffuse haze of expelled gas. For a natural body, that abrupt cessation was almost impossible to explain. Avi Loeb, who has long argued that interstellar visitors like Oumuamua could be artificial, took particular interest. In his interviews, he explained that if 3 Atlas were a natural comet, its brightening and mass loss should be consistent with the evaporation of ice. Yet based on the data, the object would have lost nearly a tenth of its entire mass when passing close to the Sun. An extraordinary event that should have left visible evidence. None was seen. The absence of that evidence suggested a different mechanism, perhaps an engineered one. At its closest approach to the Sun, on October 29th, the object performed what appeared to be a subtle but measurable maneuver. Its path deviated slightly from the purely gravitational trajectory predicted by Newtonian mechanics. For 5 months before that moment, more than 4,000 separate data points from over 220 observatories had confirmed a perfect gravitational path. Then suddenly, as it neared the Sun, it shifted, just enough for the change to be undeniable. The deviation was small, but it was there. Something had altered its motion. Scientists proposed several explanations. Some argued it was a form of outgassing too faint to detect, caused by microfractures releasing jets of vaporized material. Others speculated that solar radiation pressure, acting on a highly reflective surface, could account for the deviation. But Loeb suggested another possibility, that 3 Atlas might be using the Sun's gravitational field intentionally, the way our own spacecraft perform flybys to gain speed. It was an unsettling idea, a visitor from beyond our system maneuvering with purpose. NASA and ESA both began to reallocate telescope time. The James Webb Space Telescope adjusted its observation schedule, as did Hubble. Radio arrays listened for emissions, though none have yet been detected. The Deep Space Network turned its enormous dishes toward the object's projected path. Still, what they received was silence. No radar echo that suggested a hollow structure, no signal that hinted at communication. But the silence itself was strange, as though the object absorbed more energy than it reflected, as though it were designed to hide. In late October, just before disappearing behind the Sun, 3A Atlas was photographed by the Mars Reconnaissance Orbiter as it passed near the orbit of Mars. That image, still classified and unreleased by NASA, is said to be the highest resolution ever obtained of the object. Rumors within the astronomical community suggest that the image reveals a flattened geometry, something unlike the rounded or irregular shapes typical of asteroids. The anticipation surrounding that photograph has become almost feverish. Many scientists, including Loeb, are pushing for its release. When the object re-emerged in early November, its brightness had dropped dramatically. That could mean it had expelled a cloud of dust, reducing its reflective area, or it could indicate that some internal process had changed its orientation. New observations from the Subaru telescope showed a subtle pulsing pattern in its light curve, fluctuations occurring in regular intervals. Some researchers dismissed them as rotational effects, but others could not ignore how uniform those pulses were. They resembled faintly a repeating rhythm, a signal written in reflected sunlight. Avi Loeb's team at Harvard, working in collaboration with observatories in Arizona and South Africa, began developing a model that incorporated both the gravitational data and the photometric patterns. Their hypothesis was cautious yet provocative. If 3I Atlas were not fully natural, its propulsion might be driven by controlled reflection, like a solar sail. That would explain the deviation in trajectory and the lack of any visible exhaust. It would also explain the color shifts, as thin reflective panels could appear to change hue depending on angle and solar intensity. The implications were staggering. If the object were indeed a solar sail or similar construct, it could have originated from another star system, launched perhaps thousands of years ago. Its approach along the planetary plane could indicate deliberate targeting, a reconnaissance mission designed to gather information from multiple bodies as it passed. The idea seemed extraordinary, but then so did the evidence itself. Still, science demands patience. Loeb and his colleagues emphasized that every alternative must be tested before declaring anything artificial. The comet hypothesis remains possible, though increasingly strained. Spectral data collected from Mount Palomar indicated small traces of magnesium and nickel, metals rarely abundant in comets. Other studies found hints of crystalline structures inconsistent with frozen volatiles. Each new observation adds another thread to an ever-growing puzzle. The timeline ahead is crucial. By December 19th, 3A Atlas will be at its closest point to Earth, offering the best opportunity for direct imaging and radar reflection. NASA plans to coordinate ground-based telescopes across the United States, Europe, and Asia to capture continuous coverage as it passes. The James Webb will observe it in infrared, while Hubble focuses on visible and ultraviolet bands. Amateur astronomers are preparing as well, eager to record even a faint trace of the object's passage. What lies beyond that date could define the next chapter in our understanding of the universe. After leaving Earth's vicinity, 3A Atlas will move outward, crossing Jupiter's orbit by March 16, 2026. Its path may then take it toward the outer solar system, or beyond, back into interstellar space. Whether it fades into obscurity or becomes the first confirmed example of extraterrestrial technology, no one can yet say, but the excitement is palpable. Scientists who normally compete for telescope time are now sharing data, pooling resources, and collaborating across borders. Graduate students spend sleepless nights calibrating instruments, writing code to filter noise from the signals, and searching for subtle anomalies. Every fragment of information could be the clue that unlocks the mystery, and behind all the analysis, all the equations and spectral charts, there lingers an older, deeper feeling, one that belongs not only to science, but to the human heart. Wonder. For the first time since the arrival of Oumuamua, we stand again before an object that might not be of natural origin. We are witnessing something that could rewrite our assumptions about life in the cosmos. 3I Atlas continues to move silently, indifferent to the questions it stirs. It reflects the sunlight of our star with calm precision, as if aware of the millions of eyes turned toward it. The coming weeks will reveal more, perhaps nothing, perhaps everything. But one truth is already clear. Whatever its nature, it has reminded us that the universe is still vast, unpredictable, and full of questions we have only begun to ask. To understand the magnitude of what 3A Atlas represents, we must look not only at the object itself, but at the instruments and minds that brought it into focus. It is the culmination of decades of quiet advancement, of space telescopes designed to peer into the unknown, of observatories that stretch from the high plateaus of Chile to the frozen deserts of Antarctica, and of scientists who never stopped asking questions that most dismissed as impossible. Every beam of light captured from this object passes through thousands of hours of human labor. Engineers, programmers, astronomers, and dreamers, all bound together by the shared pursuit of understanding. Among them stands Avi Loeb, whose voice has become central to this unfolding story. His journey began not in the glare of television studios, but in the solitude of academic inquiry. For decades, Loeb has studied the faint whispers of cosmic history, from the earliest galaxies to the interstellar visitors that occasionally brush past our world. He was among the first to suggest that Oumuamua, the mysterious interstellar object detected in 2017, might have been artificial. His willingness to entertain extraordinary ideas earned both admiration and criticism. Yet Loeb's approach was never about spectacle. It was about method. Follow the evidence, wherever it leads. 3i Atlas, to him, is not proof of alien life, but an opportunity, a chance to let nature, not assumption, tell the story. He describes the object's journey as a kind of interstellar symphony. It entered the solar system quietly, perhaps having drifted for millennia through the cold between stars. It crossed the paths of planets, bathing briefly in the light of the sun before moving outward again. If it is technological, it is ancient, older than our civilization, older perhaps than the human species itself. Imagine, he says, an artifact set adrift long before our first ancestors walked upright, a relic of another intelligence, still functioning, still precise. The idea is both humbling and unsettling. The telescopes observing 3i Atlas are equally part of the narrative. The James Webb Space Telescope, with its golden mirrors unfolded against the void, is capable of detecting the faintest thermal emissions. Its data may reveal whether the object retains heat in a way no natural body could. Hubble, though older, remains indispensable, capturing visible light images with unparalleled clarity. On Earth, the Vera C. Rubin Observatory is preparing to scan its path nightly, building a detailed record of its brightness and rotation. These instruments, designed for distant galaxies and exoplanets, now turn their attention to a single traveler moving through our own celestial backyard. Even the amateur community has become part of this effort. In small towns and remote observatories, men and women who built their own telescopes are now photographing the object each night, comparing notes through online forums, and measuring its changing position with remarkable precision. This collaboration between professional and amateur astronomers is one of the quiet triumphs of modern science, a network of curiosity that spans the planet, unified by the same sense of awe. If 3i Atlas proves to be natural, it will still teach us much. Its composition, structure, and trajectory could offer clues about the formation of other planetary systems. It could show us how matter moves between the stars, carrying organic compounds that seed new worlds. But if it turns out to be something else, if even one fragment of data points toward an engineered origin, the implications would extend far beyond astronomy. It would mean that intelligence arose elsewhere, developed technology, and sent it outward, deliberately or by accident. It would mean we are not the only minds to have built machines that travel the stars. For now, the object continues its silent voyage, a cold ember of possibility gliding between the orbits of planets. On December 19th, it will make its closest pass to Earth, a moment that may define this generation of scientists. Observatories will coordinate a global campaign of observation. Data will pour in, spectra, brightness curves, radar returns, all feeding into models that attempt to decode the nature of the intruder. The world will watch in real time as the most advanced instruments ever built focus on a single, silent question mark drifting through sunlight. And yet, beyond the data and the hypotheses, there remains a deeper resonance. For centuries, humanity has looked at the night sky and wondered whether we are alone. We built stories and myths to fill the silence, then built machines to pierce it. Each mission, from Voyager to Cassini to the Mars rovers, has been an act of curiosity, made solid, a declaration that we refuse to stop asking. 3i Atlas fits perfectly into that legacy. It is both a mystery and a mirror, reflecting our own desire to know. As it moves toward Jupiter in 2026, many believe it will pass beyond the reach of our instruments. Perhaps it will vanish again into the interstellar dark, leaving only questions and data behind. Or perhaps in those final months of observation, we will see something we cannot explain away. A glint of symmetry, a heat signature too deliberate to dismiss, a pattern that demands a new vocabulary of science. Whatever happens, this story will mark a turning point. The search for truth among the stars will not end here. It will only grow bolder. In the quiet hours after midnight, when telescopes track 3i Atlas against the background of stars, one can almost imagine what it must have seen. The cold birthplaces of suns, the frozen oceans of distant worlds, the faint electromagnetic whispers of civilizations too far away to see. Whether it is natural or made, this object carries with it a reminder. The universe is alive with motion, with story, with infinite possibility. And perhaps, somewhere out there, the makers, if there ever were any, still drift beneath another sun, unaware that their creation has reached us. Or perhaps they are watching, as we now watch, waiting to see what we will do when we finally meet the evidence that we are not alone. Whatever the answer, 3i Atlas has already achieved something extraordinary. It has united our planet, for a brief moment, in wonder. It has turned telescopes and minds toward the same horizon, and reminded us that science, at its heart, is not merely the pursuit of knowledge, it is the celebration of curiosity itself. When future generations look back on this era, they may not remember the technical details or the endless debates. They may remember instead that once, in the early 21st century, humanity looked toward the sun and saw an object unlike any before. And for a moment, we felt again what our ancestors must have felt when they first looked up and realized the stars were not just lights, but worlds. 3i Atlas has rekindled that feeling. The trembling mixture of fear and wonder that reminds us what it means to be explorers in a cosmic ocean still uncharted. The story is not over. It is only beginning.